Is it up?
Yep.
Yeah, so I'm going ahead. So welcome guys to the demo and presentation of zkGATE. We have ideated and built this during ETH Shanghai entirely from scratch. And we are a team of two and are just college graduates as beginners in the Web3 space, trying to create something meaningful. So as you can see here, all the data, which is the list of different data breaches which has happened in the past, risking users' private data at stake. And this list goes on and on. So while we logging into any app, when we click on sign in with Google, the third party app which has integrated Google as the sign-in mechanism, has all the access to our personal data, which Google has in its database. So even though the app might strictly require only a few information fields like email, location, etc., according to its need, it can save other information fields into its database, which could be leaked later somehow and result in privacy breach. So here comes a new login solution, which is a zkGATE. So here is how zkGATE differs from other login protocols. Unlike other login mechanism in the app, which saves unnecessary private information, zkGATE only passes the relevant data field that is required by the app, and the rest it encrypts as proof and mints an NFT with the proof written in the NFT's metadata. The advantage of using this NFT operation mechanism would be like if a login mechanism is integrated, if zkGATE is integrated into any third-party app as login. So suppose the user one wants to give access of its account to user 2 for a day, so he can mint an NFT with a day timestamp, and the user 2 gets an access of the user one's account without the knowledge of his user ID and actual password. And since the validity of this NFT is for a day, he will lose the access after a day and can't even try to alter the original password to indefinitely get the user one logged out. So full control remains with the true owner of the account. And let's come to the functioning. So as the third party app integrates zkGATE, it generates a secret key to zkGATE, and zkGATE securely saves the secret. The public key is the hash of the secret and is accessible by all. So when user wants to sign up to the third party app, then since he's a new user, he is redirected to the zkGATE app to mint the zkGATE NFT for getting the access. On the zkGATE page, he connects his wallet, and then to authorize that the user is a genuine person, he needs to authorize through Google. And in response, Google sends the user's personal identification data to the zkGATE, like name, email, location, profile pic, link, etc. This step is necessary as this gives a sense of Google's trust to the third-party app that the user who is creating the account is a genuine one. Now, zkGATE sends only that data which is required by the app to let the app create account in its database and generates a proof with its secret key and the personal information. This proof is written in the NFT's metadata, and the NFT is minted to the user's wallet address. Now the user can go to the third-party app, and as soon as he connects his wallet to login, it is fetched that whether the user has an NFT or not, and if it has the NFT, whether the proof is valid or not, and if both satisfies, the user is granted the access. So now let's go to the demo. So here for demo purpose, we created a Learn app, which is actually a third-party app, you can say, which has integrated zkGATE as a login solution. So when we press connect a wallet with zkGATE, and when we do next, so you see here, it fetches and says access denied as it is a new user. So we need to generate the NFT for this app. So we go to the zkGATE, which is our application, and we'll connect the wallet. So once the wallet is connected, here these are all the apps which has integrated. So we have added it for a, like on Netflix also, it could be integrated later on. So generate with Google, when we do that, so it will take our data, and here are all the data which it returns, like my email ID, my name, all of those things. So now, but it only needs only few of the information. So we'll do generate, and this will generate the proof. Once this proof is generated, a MetaMask pop-up will happen to mint the NFT. So it looks like the Matic network appears to be busy. Okay, yeah. So here we confirm the transaction. And since we don't need all, the app might not be requiring to need all these information, like what is my language or what is my picture link. So we will try to uh, encrypt those information along with the secret key which it gives. So it says the NFT generated successfully. So if we go here in this and again try to log in on the third party app here, so see, it says that successfully logged in. So it fetches the NFT metadata. 1 minute. Yeah. So here if we see the transaction, So 25 seconds ago, this mint was called, which would be having my metadata, and then that is fetched in this app, and it checks and give me the access. That yeah, I got the access that way. I have the NFT, and the proof which it is having is the valid proof there. So this is it. So we have used the chain ID for all the contract verification and implementation purpose, and if for other security purposes to validate the other secondary proofs, what we have done is that we have created a nullifier of the user hash and saved it in the database. So let's suppose if somebody somehow, that is not possible, we have kept all everything as private, but if its proof gets leaked out, so in the database the second instance of that proof cannot be saved, so that will be automatically nullified, that a fake proof has been generated, which safeguards the process of the user. Yeah, thank you guys.